Hello guys, this is Miss Abellan. Today we're gonna see fossils and the age of the Earth. Check out this very cool image that I have for you from an artist that I like very much. His name is Tamura, and here you can see the size of a person in comparison with some of the fossils that have been found. Some of them are herbivores, some of them are carnivores. But how do we know that any of this is actually like the scientists say that it is? How do we know what happened before on Earth? How do we know how old Earth is? Let's see if you've been paying attention. Do you know how old Earth is? Is it A, 9 billion years, B, 12,000 years, C, 4.567 billion years, or D, 160 million years? If you answered 4.567, you are absolutely correct. And this number is actually very easy to memorize because look, it's 4, 5, 6, 7, and then billion years old. So Earth's been around for quite a long time. And like we've been studying on the timeline that we've been doing, most of this time has been that Earth, much of it nothing happened, and then life came to be around 4 billion years later, and then life began as we know it around 65 million years ago. And the time that we've been on Earth is very, very small, so that if we compare it to a clock, it's like a minute ago. If the Earth has been around for 24 hours, we've been around for like a minute. But how do we know that any of this is actually true? How do we know that Earth has changed this way over time? How do you think scientists get to these conclusions? Fossils is the way in which scientists get to these conclusions. But what are fossils? Well, fossils are remains of organisms that once lived on the Earth. They can be fish, they can be dinosaur, they can be strange ocean creatures. And fossils have been found in many, many ways along every place on Earth. They have been found buried, frozen. They have been found petrified, which means that the living tissue, all of the bones and all of the muscles are replaced by minerals. So nothing is left of the original fossil except just like a trace or an imprint, or maybe they can find a footprint, or perhaps they found a whole bone, sometimes a whole dinosaur, other times just body parts or just parts of a skeleton. What can fossils really tell us about Earth in the past and how Earth has been? Well, fossils can tell us about the climate conditions of past eras. Say that we excavate underneath our classroom, and we find 30 meters down a rock that looks like this, and that has the imprint of a fish. What do you think we would assume about that rock and about that fish? Well, probably that the organisms that were down there at some point lived under the sea. Probably also if we excavated under our house and found this, we would assume that that was the climate around that era, that was how life was around that time. It can also tell us how organisms were related to each other. Notice this image of a dinosaur, and in its belly right here, because over here is the head, over here are the feet, and this is the belly. You see the arms of the dinosaur? And this belly is filled with seeds of a certain plant. So that tells us that the dinosaur was a herbivore. Well, on this other fish, we find another fish inside its belly, which tells us that this fish was a carnivore and that it ate these other type of fish. So it also tells us how organisms related to each other and their diet and how they used to live. Finally, we can see how organisms lived because they give us a clue of what Earth was like in the past, and they tell us how Earth has changed. All of these fossils that we now know, we compile them into one big record, the fossil record, that includes all of the fossils that have been discovered. Let's see if you know. In what type of rock would it be more probable to find a fossil? Igneous, sedimentary, metamorphic, or all types of rock? If you answered sedimentary, you are absolutely correct. It is much easier to find a fossil inside sedimentary rock because it's covered by sediments. If the fossil had to survive in, say, igneous rock, for example, that igneous rock would completely melt. If the fossil would have to survive in metamorphic rock, the pressure of it would cause it to melt as well. So sedimentary rock is the best rock for fossils to form. But how do fossils form? Let's watch this animation so we understand how fossilization forms. The reality is, most animals do not become fossils. because when a plant or animal dies, usually his corpse is eaten by something, its bones are destroyed, and so it's really hard for an organism to actually become a fossil because most of its parts are, well, all around the place. But sometimes an animal or a plant dies in just the right form and in just the right circumstances and in the right place. So its body or parts of it are protected from scavengers that are going to eat it, and they're buried in the sand, in the oil, in the mud, or in a riverbed. As time passes, the fossil is buried deeper and deeper, and it's compressed into the rock. Fossilization can only happen about 2 meters or 3.5 meters underground, where the rock is really compressed into the fossil, and a nodule starts to form. After a long time, the layers of sediments compact the bone, and they start covering it and covering it and covering it, so that the fossil will be buried deeper and deeper, and it will be compressed by pressure but not by heat. After many, many millions of years, the fossil can be exposed by many reasons, and when it's exposed, it calls the attention of people. People call what we know as paleontologists, someone who's going to come in and find the fossil and excavate around it so that they can recover what they know of the fossil. Paleontologists are scientists that work excavating and investigating fossils. In the summary, you can see all the steps of fossil formation. Make sure you write them in your notebook so that you have everything that you need for the test. Remember Ross from Friends? Well, he's a paleontologist, a scientist who studies fossils. Paleontologists figure out how old a fossil is by using two very different methods. First method is called absolute dating, and it establishes exactly how many years ago an event took place, using carbon dating or radioactive elements. A second way to do it is using relative dating, which establishes a sequence or an order of events using logic and previous information. In this class, we're going to use relative dating, but probably in years ahead, you'll be figuring out how they do it by absolute dating. Perhaps the best way to explain relative dating is using something that we know, like for example, phones. If you found somebody that was dead and that was carrying one of these amazing phones, you would say this person is very modern or is probably from a recent age. If you found a body of a person with a phone like this one, you would probably say that this person lived in around the 20s or the 30s. Because phones have changed so much during such little time, it is a good way for us to establish the age of a person. In that way, paleontologists use index fossils or organisms that are known to have lived in a particular age or in a particular time. So say for example, the paleontologists are excavating and they find this dinosaur, and next to it they find certain other fossils. They can guess that the fossils that they find near this dinosaur are definitely around the age of the dinosaur. A type of relative dating that is very common is superposition. To explain superposition, I'm going to compare it with something that we know well. Say a pizza. A pizza starts with the base pan, then the golden crust, then the inner tomato sauce, then the outer cheese, then the pepperoni or the mushrooms or the slices of pepper. And all of them are in definite layers. Here's another example of geology pizza. The first one has the base pan, the second the crust, the third one has the provolone, the fourth one has the sauce, the outer cheese, and the top the sphere. Well, just like that, paleontologists use logic, which tells them that what? Well, the one in the bottom was probably the one that was added first, and the one on the top was probably the one that was added last, right? So this type of logic is what they use to figure out the deeper an organism is found, the older an organism is. This principle, which is very known around paleontologists, is known as the law of superposition. Older layers will be on the bottom and younger layers will be on the top. So what's the difference between absolute and relative aging? In this picture you can see relative aging is about estimating who's younger and who's older and placing them in order, while numerical dating or absolute dating is about using different techniques to assign a number to the age of every fossil. Let's see how well you do in this exercise. Can you guess which is the oldest rock in each of these three pictures? I guess this one was fairly easy for you, right? The oldest rock will be E, the one in the bottom. But what about this picture? In the second picture, A will be the top layer, B would be around the second layer, but C is coming from a volcano. It's magma that's erupting. In that case, the oldest rock would have to be B because C is magma that's erupting. And in the third picture, we have A is the rock in which the fossil is, and B is the rock that is surrounding the fossil. In this case, A is going to be the oldest rock, while B is going to be the youngest rock because it was laid on top after the fossil was already dead. In conclusion, we know how old Earth is because of the arduous work of paleontologists who use relative dating and superposition, absolute dating, and index fossils to study the mysteries of our Earth. This is it for fossils. Have a great day!